He's back with another screencast. Okay, this one's going to focus on doing some calculations involving the mole, okay, particularly using Avogadro's number. And so essentially we can look at this. There are various ways we can look at this, but one way I think is helpful is to say that basically Avogadro's number 6.02 times 10 to the 23 is the amount of particles of anything in a mole. So you can look at the equation this way. It's 6.02 times 10 to the 23 per mole, or you can look at the relationship this way, that really 6.02 times 10 to the 23 anythings are in a mole. Okay, a mole of that anythings. All right, so one question, looking through some of the questions that we are confronted with here is, what is the amount of oxygen O2? What amount of oxygen O2 contains 1.8 times 10 to the 22 molecules? Well, a couple things to notice right away is that when it's asking for an amount, okay, even if it doesn't say report this in moles or whatever, when we see amount in chemistry, we should think moles. Okay, so when we see amount written like this, we should think moles. This is moles. It's better to think of amount as meaning moles. It's a more pure amount rather than the mass. Mass obscures that a little bit. So when we see amount, we want to think moles. All right. So we have 1.8 times 10 to the 22 molecules of O2. Probably also very important is to realize that this is a molecule, right? O2 is the molecule. It seems kind of fundamental, but as such, it's fundamentally important. O2 is a molecule, and it is made up of 2 atoms of oxygen, right? So it's important that we are confident in using that vocabulary. So we have 1.8 times 10 to the 22 molecules. We know that there in 1 mole there's 6.02. So we need to somehow use the fact that 6.02 times 10 to the 23 molecules. Can't spell it, but molecules are in 1 mole. Okay, we need to use this conversion factor somehow, because our final target unit is going to be whatever it is. It has to be moles of O2. So we want to convert that into moles of O2. So in other words, we need the mole on top. Okay, we need the mole as a numerator here. See? So how do we use this expression then, given that we need moles as a numerator? Well, we have to flip it, right? Now, if you saw that right away and you were like, I get it, I have to take 1.8 times 10 to the 22, and I have to divide that by 6.02 times 10 to the 23, that's great. You're doing the right thing. I'm going to show it like this with the unit analysis, because to me and to my mind, that helps make it work out and helps you not make a mistake. But you have to basically multiply by, the reciprocal of this. In other words, divide by 6.02 times 10 to the 23. That's going to make sure that you get the units working out correctly, so that molecules cancels. You do the math on that, and you end up with 0.03 moles. 0.030 moles. All right. One thing that might be helpful to tease out here as well is that when you see 1.8 times 10 to the 22, really, to me, I want to standardize it and have a 10 to the 23 term. So to do that, if I make this number bigger, I have to make this number smaller, is the way I always think. So this is basically 0.18 times 10 to the 23. And I punch that in and process it to end up with the 0.03 moles of oxygen. All right, another one here. How many H atoms, hydrogen atoms, are contained in 1 mole of ethanol? All right, so if we look at the molecule of ethanol, you can hopefully see that there's 6 hydrogen atoms in there. Okay, so in one molecule we have 6 hydrogen atoms. That's kind of our first important ratio. We have 6 H atoms per C2H5OH molecule. Okay, so we want to know how many are contained in a mole. So, it's 6. Okay, it's 6 moles. Now, if you just look at that and get to the right answer, great. I'll show you how you can do it to make sure it makes sense and you don't make a mistake if you want to use my method. So, lay out that we've got 1 mole of ethanol molecules. All right, and we know that we're going to multiply it basically by this factor up here. There's 6 H atoms in every 1 molecule of that thing. And so we know we have to multiply by 6 because that's going to make molecules drop out. Okay, and it's going to give us our result in moles. So that's 6 moles of H atoms. Okay, so it didn't really specify here. Does it want us to answer the question of how many? Does it want us to answer that in moles, or does it want us to say literally how many is 6 moles? In that case, we have to multiply it by Avogadro's number. So let's do that anyways, just in case that's what it's after. Okay, so we're going to have to take that. This is going to be an or you could answer that 6 moles of H atoms. You're going to multiply that by the fact that there's 6.02 times 10 to the 23 anythings in a mole. Okay, and when you do the math on that, the mole is going to drop out and you're going to have a literal number of hydrogen atoms. And that number is, it works out to be 36 times 10 to the 23, which you then put in proper scientific notation. It's 3.6 times 10 to the 24 hydrogen atoms. There you go. Hopefully that was helpful.